Hello guys and welcome to this video. In this tutorial we will be looking at classes, and this comes under a concept known as object-oriented programming, right? So this concept provides us the tool set to be able to create our own objects, define their attributes and their methods or functions, or basically what they should be doing. For example, we've been using integers, we've been using floats, we've been using strings, and these are data sets that come along with the C++ programming language. So when you use the data type int and you have 3 added to 4, what you would have is another integer. And this character, this addition, is a function of the data type integers. But when you have a string, you cannot just add a string, let's say hello, plus another string, because that is not the attribute of that particular data type. So we have data types and we have functions that we can perform on them. We can subtract integers, but we cannot subtract strings. So they come with their attributes and their functions. So the function is addition under integers, and for strings we can concatenate them as in other programming languages. So objects have their own characteristics and they have their functions that they can perform under a class or under a common container. So since this is basically the core of programming language, I would like to dwell a little on the theory. So I would like to give you guys an intuition behind the classes. So let's take for example that a class is a container, right? So just a container. So let's just say container A, and you have a collection of objects in that particular container, and you have another container called B, and you might, whoops, I mistakenly pressed shift B. That's my key combination for run. So I use caps lock B. Okay, so container B, and in that order you can have several of them, as much as you want. Now in container A, you would want to store certain objects of same type. So those objects which will be in container A will not be in container B, because you want to separate them based on the characteristics that they have. So you might want to put small objects, small yellow objects here, and then you might want to put large green objects in here. So when you pick an object from container A, you would expect it to have an attribute of, let's say, it should be small and it should be yellow, or it can be yellow. And when you pick an object from container B, you should expect it to be large and green. And let's say some objects of container A, you want to use them for a certain function, and for those ones under B, you would want to use them for a different function as well. So basically this is what containers classes allows us to do. So you have this collection, and anytime you want to perform that particular function, you just go to that particular container and then fetch the object and then use it. When we use an example in a bit, you would kind of get the right intuition behind it, because most of the times abstract things are quite difficult to grasp. So with this said, I would like to continue with a comparison between structures and classes. So basically classes are a kind of extension of structures because there is more functionality with classes. So we've looked at structures in a previous video, and I believe in learning by association. So I would start with structures first and then just smoothly run into classes. And it's a good practice to define your structures outside of the function. Now before we continue, I would like to just point out some details in this. Now these are the two lines. This one is basically included in every C++ programming language, program. And then with this one, I included this in order to be able to have a lot of these source files over here. If you are using code blocks, you would understand what I'm saying. And with this, we define a constant t to denote in a tab. So we do not want to be inputting this character for a tab, and then we don't want to be inputting this character for new line, or in most programming environments where you see the semicolon, and with that ENDL. We don't want that. We just want to use NL for that. And this is the standard using namespace std. And you will most probably be running your program in the int main function, but I will be running it in the void class function. It's going to be the same output. So much talking, so I'll just define my structure, using the struct keyword, and we want to call this product. So this is a structure called product, right? Now in this structure, what do we want our product to have? The qualities we want it to have, and let's use a double weight. So let's say this is an online shopping something, and you pick a product. The product should have a weight and a double price tag, and let's just give it a name as well. So string name, right? So we have created our structure. Then we want to create an object of this particular structure. So how do we go about it? You just call the name of the structure. So this is just a quick recap. Product, and we want to call our first product shipment 1, right? Then after that, we want to assign qualities to this shipment 1. This product that we are calling shipment 1, what attributes does it have? So, or it has attributes like weight, price, name, because it's under a structure called product. So then we want to assign those attributes what exactly they are. So we want to say that shipment 1 dot let's start with the name first, is equal to, we want to call it let's just say computer. So we are buying a computer, right? And then we want to say that shipment 1, since we are not dwelling much on structures, let me just leave this. Then after that, we might want to print it out to be sure, or whatever you want to use it for. So see out the product you bought. So the product you bought is a, want to have is a shipment.name. You could have stored this in a variable and then printed the variable instead of the explicit calling as such. So what we'll be doing over here is we want to use a new line instead of the ENDL, right? So we would run this to see the output. And we have the product you bought as a computer, right? So this is a structure. Now, how do we define classes? So over here we use the struct keyword. So what we just have to do is to replace this with class, and this becomes a class. Basically, this becomes a class. This syntax is applicable to classes as well. So basically, this is how to define a class. Now, I would like to talk more on classes again. Now, when we talk about classes, we have 3 major components. We have the attributes. So let me write it over here. So we have the, what we call the attributes. And these are basically the qualities of the product, data that you assign to the product. So over here we have the product called shipment 1, and shipment 1 has qualities or attributes such as weight, price, and a name. These are attributes. So the second component of a class is what we call the method. So let's just say methods. So methods are basically functions. Now we've talked about functions already. And when you include a function under a class, then that function technically becomes a method. Even though it has the same syntax as a function, the name over here, the technical name, is what we call methods. So methods are basically functions that are defined under a class. Simple. And we'll be looking at those in a bit. So right now we just want to have a quick introduction to classes. Now the third component is what we call access specifiers. Access specifiers. I hope I spelled that right. Right. And these basically tell us how the scope to which we can use an attribute or a method. And these access specifiers are just two. We have the private specifier. It's private and public. And be looking at how applicable they are in a minute. Right, so these are the 3 major components. So these are attributes. Now, when we run this, so let me just a quick recap. So we've defined a class called product, and we've given the attributes to this class. That means that any object that would be declared using the product class would have these attributes. So we came down over here and then we declared an object called shipment1 as an object of class product. Then we assigned shipment1.name to be computer. Let's dwell much on this. So we create shipment1.price. I want to make this $89. A computer costs $89. Wow. So we would want to have shipment one dot weight, and we want to give this 1500 grams, so basically 1.5 kilograms, right? So these are the attributes of the object called computer. Now the object comes under a class called product, and so this is a container, and the container, every object under the container should have these attributes or some of these attributes. And we've created an object and we've assigned those attributes to it. And what we want to do right now is to just print it out. The product you bought is a computer. It's a computer. Then we want to put in a full stop over there. And we want to have it. So it costs, let's say shipment1 dot price. So it costs shipment1 dot price and weighs, let me put a space here, and weighs. So we want to have shipment1 dot weight, right. So we will be running this, and whoops, we have an error over here. It says that string product name is private. Good. So over here we've talked about access specifiers already, and they are private and public. Now it tells us over here that we have an error that name is private within this context. Now for private access, for private attributes, you can only use them within these brackets. You can't ever call a private attribute or a private method outside of these brackets. We have tried calling it outside of those brackets, and so we can't access it because it is set to private. Now we can change this to public by writing it over here to just make all of the following attributes and methods set to public. So I'll go ahead and index this, even though it's not really necessary, but it make the code presentable, right? So we've now set the attributes to public, so we can now access them outside of those two brackets, defining the scope of the class. So we run this and hopefully we should not be getting any error. Good. So the product you bought is a computer. It costs $89 and weighs 1500, no units. Okay, so now you might have wondered that we did not have any private here. So why is it that it did not run? Now the automatic or the default access specifier is private. So if you do not specify it, automatically it sets it to private. So you can explicitly state it this way as well. And we run this and it's not going to work. We can't call it outside of it. So we have to set this to public. Okay, so one other thing is you might want to set some to public and set some to private. So let's say that we want to set the name to private for whatever reason that we want. I don't know. So we want to set this to private. So we can't access this outside of the confines of these two curly brackets. So we run this and we would have that the name is all of that. So we can just comment this out and come over here And what do we put over here? This is going to be a problem. So let's just okay, let's just explicitly write it here, even though that's not a good practice for the sake of this example. So it computer, so we run this, and now we would have an output, right? So later on, when we look at methods and functions, we would use some under private mode and some under public mode, so that you kind of get the real feel of it. But I hope with this you get the intuition behind private and public as it specifies. So I'll just go ahead and undo this, and we continue to the next section. Now we can also create other objects. So you can have product and you can have shipment too, right? We've created another object, and to this object we only want to assign just a name. That's it, just a name. And we are saying that this is going to be a pen drive. So even though it has the right to have a price attribute or a weight attribute, we are only giving it a name attribute, but it can also have a price attribute as well. Good. So we have created this object, and you can go ahead and assign attributes to it and print it or do whatever you want with it. Now the thing I want you guys to take note from this section is, let's say we have int a. This is an object under, let's say, a class called integers, and then we can say a dot price. We can't say a dot price because a is not an object of this particular class. It's only this class that has an attribute called price. Integers don't have attributes called price. So when we run this, we should be getting an error. So it says, okay, so this is still the private something something. So let's just go ahead and set it to public so that we don't have these kind of errors. So I've set it to public over here, and I'm now going to run this, and hopefully we should be getting an error down there. Good. So it says that request for member price in A, which is of non-class type, whatever. So we can't be doing this because it's not an object of class product. In order to do this, we should use the product over here, not an int, because product is now a class just like an integer, and we are now creating an object called a, which is of a class product. And now we can access a dot price, and we can set it to whatever value that we want. Let's just run this, and hopefully we should not be getting an error. Good. So we don't have an error, right? So I just hope that you guys have the intuition behind classes. In the next section, we will be looking at methods and functions and constructors and a whole lot of tools that this provides us.